Hello, and welcome back for part 2 of Groove Welds. In the beginning of this video, I'm just going to give a short reintroduction to groove welds, and then we'll go ahead and start talking about the different types of grooves, and then we'll start looking at the different types of welding symbols that are often used with groove welds. So to start off, let's say we have two plates of metal. Two plates with no edge preparation, they're just called square edge. And we have them real close together, and say you want to weld from one side through all the way to the other side. Well, if you're using something like 6010 that has high penetration, you might be able to do so depending on the thickness of the plate. But how can we really be sure that we've reached all the way through to the backside and still maintain sound fusion along with sound penetration? So like I was saying, depending on the thickness of the plate, you might be able to weld all the way through from the top to the bottom. Like with the case of having plate that is 1/8 inch in thickness, there's a really good chance, depending on your variables, you can melt through all the way to the backside and not even have to space your materials out in order to do it. But if you were to try the exact same thing with plates that were, say, 1 inch in thickness, it's probably going to be a little more difficult, even if you have the plates spaced apart so you can get you can get your electrode in between them a little bit better. It's still going to pose a challenge. So again, we need to think about how do we achieve acceptable penetration and acceptable fusion at the same time. This is where we start incorporating groove welds. So basically, we're going to take our plates, no matter their thickness. We can be dealing with something as thin as 3/8 of an inch or maybe a little bit thinner. And we can be dealing with plate upwards around 2 inches and sometimes even thicker than that. And what we're going to do is we're going to remove a little bit of material off the edge. This is called beveling. And then this is going to allow us to reach even deeper into that weld joint in order to achieve desirable level of penetration while getting good fusion. So if you'll remember back to the part 1 video where we were etching the T-joints, the fillet weld T-joints were only getting partial joint penetration, or PJP, and groove welds allow us to achieve complete joint penetration, or CJP. Okay, now that we finished with the brief recap intro, let's go ahead and start talking about the types of grooves that we can encounter in the industry. The first groove we're going to talk about is probably the most recognizable. It's called the V groove. This occurs when both plates meet together in a butt joint and they are both beveled. So each plate has a bevel, and when they come together, the shape of the groove forms a V. The next groove weld we're going to be talking about is the single bevel. So this is when we have two plates that come together in something like a butt joint, and only one of them has material removed from its edge, or only one of the plates is beveled. So when they come together, the shape in between them, you can almost draw like a check mark. So one of them is a square edge, the other one receives a bevel. And it doesn't matter which plate is beveled. As long as one of them has a bevel, it's considered a single bevel groove weld. Okay, so let's see if you've been paying attention so far. We talked about a V groove, we talked about a single bevel. Now, what happens if you have two plates that come together and both of them are beveled? Is that considered a double bevel? No. This is actually what we would call the V groove. Remember, if the groove forms a V, then it's a V groove. If only one plate is beveled, then it's a single bevel. Now, a double bevel occurs when one plate, or at least one plate, is beveled on both sides, so on the top and on the bottom. Now, the next groove is the J groove. So when you have two plates butted up against each other, one of them is going to receive this type of preparation. So instead of like the single bevel or a V groove where the material is beveled at a straight angle, with the J groove, it's almost like you're carving out half of a U from the edge. Now the J groove can also vary in size. You can groove out a little bit or you can groove out a lot. It just depends on the application and what you're trying to do. Nonetheless, if as long as one of the plates has this preparation, it's considered a single J. But now, if you have two plates that are butted against each other and both of them have been prepared with a J groove, does this make a double J? No, this actually makes a U groove. So when you're beveling these plates with a J groove, remember, a single J groove is like carving out half of a U. So if both plates have a J groove, they're going to form a U in between them. This makes a U groove. So it's pretty similar to how a V groove and a bevel or single bevel and a double bevel work out. So a double J groove would occur when one plate has a J groove applied to both sides, the top and the bottom. So now we've talked about a U groove, we've talked about a J groove, and we've talked about a double J. But what about a double U? A double U groove occurs when both plates have a U groove applied to the top and the bottom. Those are some of the most common groove welds that you'll see being prepared in the industry. So, with that being covered, let's go ahead and start talking about the different elements of a groove. And let's start with the easiest one. Let's start with the bevels. The bevels are when you take the plate and you remove a little bit of material off the edge at an angle, so that way your welding electrode can reach deeper into the root and allow you to obtain more penetration. So the bevel is the angled cut applied to one or both plates. And whether one plate is beveled or the other plate is beveled, this creates the groove. Now, the next part, which is called the depth of bevel, is how far down past the surface of the plate do we carve out the material, or how far past the surface do we remove or bevel, whatever the preparation is, just how deep into the plate are we removing material. And the other part to the groove is the angle. So the angle of which we are removing material from one or both plates. Now, if one plate is having material removed, then it's just called the bevel angle. If both of them are having material removed, then it's still the bevel angle, but each one has its own bevel angle, which come together to create what's called the groove angle. And then whether or not the plates are spaced apart or they're butted up right against each other, the root of the weld or the root of the joint, the root of the groove, however you want to call it, this is basically the bottom of the weldment. So when you're trying to reach all the way deep into that joint, what you're trying to hit is the root of the groove. And in the event that you're not beveling all the way down to the bottom edge of the plate, if you have a little bit left over, say like a little flat edge, this is what we call the root face. Okay, so let's bring it all together now. So we have the root of the weld, then we have the bevel or bevels that are applied to one or both plates. We have the depth of bevel, or the depth at which the bevel is applied to one or both plates. Then we have the root face, which would happen in the event that we don't bevel all the way down. Then we have the angle at which the bevel is applied, or what's called the bevel angle. And now, whether or not one plate or both plates are beveled in some way, the angle, the total combined angle for this weldment is going to comprise the groove angle. Oh, and one other thing I forgot to mention, the spacing at which the two plates are set apart from each other, this is what's called the root gap. Now let's go ahead and take a look at some of the symbols for the grooves that we just talked about. So as we go through these weld symbols, just imagine that they're being written down on a reference line, where you would typically see all weld symbols being drawn on a blueprint. So the first one we're going to start with is probably the most recognized. It's going to be a V. And so when this is written on a reference line, this is going to let you know that the plates need to be prepared in a V groove. Now, if it's written on the top of the reference line, it's going to form what looks like a V. If it's written on the bottom of the reference line, it's still going to form a V, but it's going to be upside down. Now, the next one is going to be for the single bevel. Think of this as half of a V or a really big check mark. So the vertical side, or the side that goes straight up and down, is always going to be on the left. Now, if it's written on the top of the reference line, this is where it's going to look like half of a V or a really big check mark. If it's written on the bottom of the reference line, it's going to form the same shape, but it's going to be upside down. Now, the third one is going to be the single J. This is when you have a vertical line on the left-hand side, and you're going to have half of a U drawn on it starting at about the middle of the line. So this is how it's written on the top of the reference line, and when it's written on the bottom of the reference line, it's going to resemble a lowercase h. Or you can look at it in terms of a capital J that's been rotated on its axis. Then continuing on with more weld symbols, the next one we're going to talk about is a U groove. Now, when written on the top of the reference line, it's going to look kind of like an uppercase Y. And when it's written on the bottom of the reference line, it's going to look the same way, just upside down. The next one is a square groove, which just resembles two I's or two ones, just depending on how your handwriting is. And it's written both on top and bottom in the same way. Now, at this point, you should be recognizing a pattern. The weld symbol often resembles the exact same preparation you would be applying to one or both plates, depending on the symbol. And the next one is one that we haven't talked about, but it's called a flare V. This is when both plates have been given a flare, and on the top of the reference line it looks like this, and on the bottom of the reference line it's just upside down. Now let's take a look at these in a practical application. So starting with the single bevel, you could come across a single bevel on the reference line that looks something like this, where the reference line is pointing to the right and the bevel is on the arrow side, or you can come across a reference line where it's coming from the right and pointing to the left, and the weld symbol again is on the bottom side. Now, if you remember back to an earlier video I made, whether the weld symbol is on the top or bottom, that is going to tell us the side significance. So if the symbol is on the bottom, this is the arrow side, and if the weld symbol is on the top of the reference line, that's the other side, and that's going to tell us where the weld needs to go. But in terms of joint preparation, the reference line is also going to tell us what side or which plates we need to prepare with a bevel or with the J groove or whatever it happens to be. So when we're looking at the reference line, we need to be paying attention to the direction that it's pointing. So with the first one, when it's coming in from the left and pointing to the right, that's letting us know that the right plate needs to be prepared with a bevel. Now with the second symbol where it's pointing to the left, this is telling us that the left plate needs to be beveled. And we also need to pay attention to whether or not the reference line is pointing down or up. If it's pointing down and the weld symbol is on the arrow side, then we need to apply that preparation exactly where it's pointing to. If it's on the if it's on the other side, then we need to apply that preparation to the opposite side. So this is where we need to start paying close attention to the weld symbol and exactly where the reference line is pointing to. Just the same, if we were to encounter a reference line that tells us that we need to have a double bevel, we need to pay attention to which direction the reference line is pointing. So in this first symbol, it's pointing to the right. And the second symbol, it's pointing to the left. So if we were to go with the first double bevel example, with the reference line pointing to the right, we would apply that double bevel preparation to the right plate. And if we were to use the reference line that's pointing to the left, we would do the same thing just on the left plate. And now, if we were to encounter a reference line that includes the symbol for a V groove on the bottom of the reference line, or what's called the arrow side, this is basically telling us that exactly where the arrow is pointing is where the V groove needs to go. So follow the arrow, and whatever side it's pointing to is where you're going to prepare. Just the same, if the reference line was coming from the right and pointing to the left, the V groove is still on the arrow side, so exactly where it's pointing is where we're going to prepare the material. So if it's pointing down on top of the plates, we're preparing the top of the plates. If it's actually pointing up, then it's probably going to be located below the plates, and we'll be beveling the bottoms of the plates. So we just need to pay attention to where it's pointing. And here we have a reference line with the weld symbol for a J groove. So remember, this looks like a lowercase h when it appears on the bottom of the reference line or on the arrow side. So as you can see, it's coming from the right and pointing to the left. So with the preparation being annotated on the arrow side of the reference line, we just follow the reference line to whichever plate it's pointing to, and we are going to prepare that plate with a J groove. So in this drawing, I'm just kind of saying that the reference line is pointing to the left, just like in the previous weld symbol. So with a J groove, we would be applying that preparation to the left plate, as we see here. And just the opposite, if the reference line were coming in from the left and pointing to the right, then we would apply the J groove preparation to the right plate. Now here's this welding symbol element chart that you should remember from one of my previous videos. So I know some of the information is kind of hanging off the boundaries of the screen, but that's okay. That stuff is, we don't have to worry about it. What I really want you to pay attention to on this reference line is just the reference line itself, which direction it's pointing to, and some of the elements on there to include those brackets in the middle. That's pretty much the location where the weld symbols are going to appear. So right at the middle section of the reference line, whether it's the arrow side, other side, or both sides. We're also going to be looking at the letter E just to the immediate left in parentheses. This is going to be the size of the groove weld. Then the letter S to the immediate left of that, which is going to tell us the depth of bevel for the groove welds, or basically the depth at which we are removing material, whether it's for a single bevel, a V groove, a J groove, a U groove, whatever it happens to be. This is going to tell us how deep into the plate we're removing material. And then we're also going to be looking at the letter R, which is just above the reference line. So this is kind of the placeholder where we would see a number that's going to tell us how far apart our plates are going to be spaced. And then we're also going to be looking at the letter A, which is the placeholder for the groove angle. So it's going to give us the groove angle, which is the combined angle of both plates. So if both plates happen to need some sort of groove preparation, then we're going to take this groove angle and we're typically going to divide it by 2, and that is going to be the groove angle that is applied to each individual plate. So again, the groove angle is the combined angle of both plates. The bevel angle is half of that. So there's a little bit of math involved, just depends on what the preparation is that's being called for. Now, I know that most of this information that we're supposed to be paying attention to is located on the top side of the reference line, or what's called the other side. Now, this information can also be found on the arrow side, but it's just going to be flipped upside down. So exactly where the E, the S, the R, and the A are located, if you were just to flip that upside down, those would give you the same locations where that information would be found if it was written on the arrow side. So let's go ahead and take a look at a couple of examples where you would find information written in these locations on the welding symbol. So let's take this first example. I'm giving you a reference line that's coming in from the left, pointing to the right. I have a weld symbol located on the arrow side, and I'm giving you 30 degrees. So when we have our two plates, this is what we're going to do. Since the reference line is pointing to the right plate, this is going to be the plate that receives the single bevel. And we also need to take into account that 30 degrees. This means that the bevel we're placing on there has to be at a 30-degree angle. And because there's no number given to the left of the weld symbol that tells us the depth of bevel, we're going to go ahead and assume that the bevel needs to be all the way through from top to bottom. So there's going to be no root face in this situation. But in the next example, if I were to give you 3/4 of an inch to the left of the weld symbol with the 30 degrees, we're going to count down or measure down 3/4 of an inch, and then that's where we're going to place our bevel. So make sure we're at 3/4 of an inch down, and then create our bevel at the 30-degree angle. Now, however thick this plate happens to be, we're going to have a root face, and that's just going to be the leftover material that we didn't end up beveling. Then let's go ahead and add a little bit more information. Let's say still single bevel. Your plate is going to be, let's say, 1 inch thick. So this is going to make sense here in a second. So 3/4 inch depth of bevel, 30-degree angle. Okay, so this is going to tell us that same thing as before. We're measuring down 3/4 of an inch, and then we're going to bevel at that point 30 degrees. And with the plate being 1 inch thick and with a 3/4 inch bevel, this is going to tell us that our root face is going to be 1/4 of an inch. So we need to do just a tiny bit of math. Some information is not going to be given to us on the welding symbol. It's just something we have to figure out on our own. Okay, let's go through some more examples. So the next one, we have two plates. You have a single bevel on the other side with a 30-degree angle. Follow the reference line to where it's pointing to, and it'll tell you which plate that you need to bevel and where. So in this case, it's pointing to the left plate, but it's on the other side of the reference line. So this means instead of the top where the reference line is pointing to directly, we're going to be beveling the bottom side. So we need to bevel the left plate on the bottom at a 30-degree angle. And the next example, it's going to get a little tricky. This is going to have a reference line with a break in it. Same thing, single bevel. So we notice that it is kind of pointing to the left, but that break has the reference line coming back to the right side. So this is something that you can see on blueprints where even though the reference line is originating on the right side and then being drawn to the left, it can have a break and come right back to the right side, and it can do the same if it were pointing upward. So there's really no universal rule on when to use this sort of break with a reference line. A lot of times engineers will just use it if there's a lot of information jam-packed on a blueprint, and it's just easier to draw it this way to make it easier for the welder to read. So we just have to pay attention to where the reference line is pointing to. And so the single bevel is still on the other side. So the reference line is pointing to the right plate, and this is going to tell us that we're going to be beveling the bottom of the right plate. All right, next example, I'm giving you a single bevel on arrow side, and I'm saying that we're going to have a 1/8 inch root gap with a 45-degree groove angle. So again, the reference line is pointing to the left plate, and this is on arrow side, so we're going to be beveling the top side of the left plate, and we're going to be beveling that at a 45-degree angle because the groove angle is 45, but only one of the plates is being beveled, so that 45-degree angle is being applied in whole to the one plate that's being beveled. And then of course we have our root gap spacing, which is going to be 1/8 of an inch. All right, next example, we're going to have a break in the reference line again. I'm giving you a single bevel on the arrow side with a 1/4 inch root gap and a groove angle of 30 degrees. So once again, just pay attention to where the reference line is pointing to, and then pay attention to what side of the reference line the weld symbol is being drawn on. So in this case, we're going to be beveling the right plate, and the bevel is going to be on top. So we're going to make sure that this bevel is prepared into the material at a 30-degree angle. And then we're going to make sure that both plates are spaced apart 1/4 of an inch. So this is our root gap. Next example, I'm giving you a couple of plates, and we're going to say that they are 1 inch in thickness. And I'm giving you the symbol for a V groove. I'm telling you that the depth of bevel is 7/8. The root gap is going to be 1/4 of an inch, and the groove angle is going to be 60 degrees. So our first step is to take each plate, measure down 7/8 of an inch, and this is going to be the bottom of the bevel. So we are going to bevel both plates at 30 degrees. So remember, the entire groove angle is 60 degrees, and we're just going to divide that in half to figure out the degree of which we are beveling each plate. So groove angle 60 degrees means that the bevel angle for each plate is 30 degrees. Now, with a depth of bevel of 7/8 of an inch on 1 inch plate, our root face is going to be 1/8 of an inch. And then of course our root gap, or the spacing between the two plates, is going to be 1/4 of an inch. And next example, we have a couple plates here. I'm giving you a V groove on the arrow side. But before I get too far, we're going to say that these plates are 3/8 of an inch in thickness, and the depth of bevel is 5/16. We're going to have a 1/8 inch root gap and groove angle of 60 degrees. So we're going to start. The weld symbol is on the arrow side. Reference line is pointing to the top of the plates. So we're going to be beveling the top of both plates, measure down 5/16 of an inch past the surface, and this is going to be our depth of bevel. Now with a 60-degree groove angle, we need to make sure that each plate is beveled at 30 degrees. Then we make sure our root gap is 1/8 of an inch, and with the plates being 3/8 of an inch in thickness with a depth of bevel of 1/16, doing a little bit of math, this is going to tell us that our root face is going to be 1/16 of an inch. Next example, couple of plates at 3/4 of an inch in thickness, and I'm giving you a V groove again on the arrow side, depth of bevel 1/2 inch, root gap 1/4 of an inch, groove angle 90 degrees, and I'm giving you this additional symbol on top of the reference line. It looks like half a circle, it's filled in. We're going to start with a depth of bevel. So we're going to measure down 1/2 of an inch on both plates. This is going to be our depth of bevel. So we're going to remove the material. We're going to put those bevels in to where the groove angle is 90 degrees. And remember, we're splitting this in half between the two plates. So each plate is going to be beveled at a 45-degree angle. Now, with both plates being 3/4 of an inch in thickness and a depth of bevel of 1/2 of an inch, our root face is going to be 1/4 of an inch. And then we're going to leave off with our 1/4 of an inch root spacing, or root gap. And then this symbol on top of the reference line is telling us that we're supposed to have some melt through. So if we put in our root weld, All that's telling us is that we need to melt a little bit further past the backside of those plates. So we're going to have a little bit of weld sticking out the other side. And I think that's enough examples for one video. I know that this is a lot of information. Please feel free to go back and re-watch some of these examples that I've given you. I hope that it's not a whole lot. Just remember, take a look back at the chart of the welding elements, welding symbol elements, and just remember that the placeholders are telling you something different about the weld. So if you see a number at a certain position on the reference line, look back at the chart, figure out what letter it's corresponding to, and it's going to tell you a different bit of information about the weld. Something simple as the groove preparation. Is it a V groove? Is it a bevel? Is it a J groove? Then what side of the reference line is it on? Is it on the arrow side or other side? And then which direction the reference line is pointing to. This is going to tell you where the groove needs to be placed. Then if there's something to the left of the bevel, or sorry, if there's something to the left of the groove weld symbol, this is typically going to be your depth of bevel. Now, if it's in parentheses, it's going to be the size of the weld, so how deep down the weld is going to reach. I really don't see this used too much because when there's no number in parentheses, just assume that it's complete joint penetration, that you're welding all the way through. If you do have a number in parentheses, then you're typically going to have a groove weld where the weld does not go all the way through. And that's a whole different scenario that I'll save for another time. Now, if you see a fraction or a number given to you within the groove weld symbol, then that's typically going to be your root gap or your root spacing. Now, if it has a little degree symbol up in the upper right hand corner, that is going to be your groove angle. Now remember, the groove angle is the combined beveled angle of both plates. If only one plate is being beveled, then the entire degree is being applied to that one plate. If there are two plates being beveled, then the groove angle is split in half evenly to the two plates. So again, rewatch the video if you need to, look over the examples, and if you have any questions, feel free to reach out.